All right. I want to go ahead and welcome everybody. Hope you're all having a wonderful day today, no matter where you happen to be in the country. So thanks for spending a little bit of your day with us today. I hope we make it worth your while. We're going to talk today about selecting the right hardware for SolidWorks, and not just specifically CAD, but SolidWorks tools in general. Now, my name is Darren, and I've been with SolidWorks and DASI and had the privilege of being here for the entirety of my career, actually. Really grew up with SolidWorks and knew it from a cute little product to really the entire ecosystem that it is today. So I really enjoyed watching the growth and the input from customers and how the software has evolved. And, through the years, I've been able to use SolidWorks not just in my professional life, but also my personal life. I have a nice little hobby. If you don't have a drone yet, I recommend them. They're very fun. But I also use SolidWorks whenever possible to go ahead and do projects around the house. So whether it happens to be utilizing the weldments tool to do a framing member and just using wood instead of steel for the profiles, or whether it happens to be building out something in your home. Anytime you have a chance to use SolidWorks, what you're really doing is just exercising your skills and really just getting better with the tool. So I like to use it in a lot of these things because for me, I'm very visual and I like to throw things on paper and be able to transfer that visual knowledge over to other people quite easily. 3D printers have really gotten into the industry and much more readily available. They're inexpensive. You can get them on Amazon these days. And they're really great for, again, experimenting with creating things and solving problems as an engineer should. Now, I like to use my 3D printer to make end-use products, whether that happens to be cobbling together something that was once one thing and I want to make it something else. I like things to look like they belong. And, SolidWorks and a 3D printer really suit each other to make that happen. So I am privileged to be an engineer at heart and found a job that really just suits me quite well. So join us on our YouTube channel. We're trying to take everybody through these journeys and show you as many things as we can about how to utilize SolidWorks in a practical manner. And, no matter who you are, novice or skilled user, you're going to gain something by watching somebody else approach something in a different way. It's just the way that the software works. So what we'd like you to do is, hit our YouTube channel whenever you can and just subscribe and allow us to build you some more content to show you these types of things. So today we're going to talk about what hardware to get. Now, we are going to talk about specific pieces, components. So of course, we're going to start with processors, always a critical consideration. And then we're going to go ahead and move over to video cards. Lots to talk about with that and other considerations as well. RAM's a pretty quick one, but things have changed there, so definitely a couple of things to make you aware of. Hard drives are really, they've always been a consideration, whether it's just a commodity for the space, and storage and how you use those. But it's not really just about where you store it or how you store it, excuse me. It's a lot about where you store it too. So this is going to delve a little bit deeper into things like where the storage is actually housed, whether it's on the local computer or the network. And then, of course, input devices. This is one of those technology things that really evolves quite often because, it has to do with how do you get your information out of your head and into the computer. And we're trying to do that in more and more ways when it comes to more visual 3D ways like scanners, especially touch screens, the way they're available, and just some of the other devices really that have been around for a long time, like the mouse and the 3D mouse. So we'll hit each of these. Now, when we're talking about each of these specific items, this is going to be a different sort of conversation. We're not necessarily going to dive into things like the difference between Sandy Bridge and Ivy Bridge processors and speeds and error checking RAM. Those types of things, of course, you can go into spec sheets and you can put them together and you really cobble together the fastest of everything that you can afford. The reality, though, is that computers these days are almost as unique as a fingerprint, and everybody's company really has to approach it and what's important for them. So I'm going to talk about each of these items, but I want you to know a little bit more about how SolidWorks uses them so that you know where you want to throw more of your money, maybe pull back a little bit and go a little more conservative in a purchase. That's really what this is all about. So let's get started with processors. Now, when we're dealing with processors, of course, we used to have to be very specific with this, but really it's just down to Intel and AMD. So it's i7, i5, i3, i9 processors out there, Xeon processors, of course, and then AMDs. Really, the only thing that's critically listed specifically on the SolidWorks resources page is the requirement for 3.3 gigahertz or higher. This one's a little surprising to me, to be honest with you, because frankly, I've never had a computer that's had that type of processor. I work in the business. I have a very strong laptop, and here's the task manager on my laptop currently. So I'm running a 6-core i7, which was an improvement over my previous quad-core i7 laptop, but I'm running at 2.6 gigahertz per core. So 3.3 gigahertz, it's a wish list item, I guess I would say, but I've never had a problem based on the processing power. If you're running an i5, i7 especially, or i9, or a Xeon, you're in good shape. It's really just a matter of some other considerations. And with AMD, they're multi-core anyways. So both of those lead me to, well, really to me is the biggest consideration with the processor. Of course, the faster it is, faster it's going to go. That's not a long conversation. What I want to talk about, though, is a little thing that specifically started with Intel, but I believe AMD is doing this as well. And it's called hyperthreading. Really, to be honest with you, this is one of the more critical issues that actually comes on every computer that is purchased. When you buy a new piece of hardware, this setting is on. And what it is it's a virtualization of the processor. So what we're seeing here is the task manager on my other office computer here. It's an AMD, actually says it's an 8-core processor up there. But what really is happening is that this happens to be a quad-core processor that's masquerading as 8 logical processors. So what that's doing is it's utilizing hyperthreading technology. What you really want to see, or what I prefer you to see, is this type of a look. And what you're looking at here is my old laptop, which was the quad-core i7. And what you're seeing is an equal number of quad cores, logical cores versus actual physical cores. So what hyperthreading does is it virtualizes things. I'm going to back up here to the previous slide. What it does is it takes what is already a multi-core processor, and frankly, you can't get away from that no matter what you do, and it turns it into double the logical cores, but at half the speed. And that's really the rub. So what you're getting is the ability to multitask more logical processors to run individual executables. And in that case, that's good. But the speed is cut down due to the hyper or the virtualization of it. So the problem that we get into this with SolidWorks especially is that CAD packages by nature are linear. And what they do is they process things one at a time. So multi-cores, multi-threaded processes are not really the basis for most CAD systems. And frankly, every CAD system that we do, or every CAD system that's out there, rebuilds their parts in the same way. Now, there are areas of SolidWorks that can utilize multi-core. When you're opening a file and you have the ability to rotate it before the feature tree rebuilds, that's a multi-threaded operation. When you're rebuilding a drawing and you see that multi-views are actually rebuilding simultaneously, you can actually see multiple executables for each of those views. So there are a few places that we can do this, but a feature tree being what it is, primarily it is a linear process. Now that said, you already have 4 cores. So you're ahead of the game when it comes to what SolidWorks is going to use. So why turn 4 into 8 or 8 into 16, as I've seen with dual quad core hyper-threaded machines? So what I recommend when it comes to SolidWorks and CAD in general is disabling hyper-threading. So to do that, and this is really the first thing I actually look for when I'm called into a company to sit down and look for performance issues. Really, it's the low-hanging fruit. Right-click the task pane, so hit your space bar, hit your Windows button, right-click down here, and just simply launch your task manager. And what that'll do is bring up this window. Now, what you'll see here, generally you'll see more squares, cubes there than you're looking for. It's just going to hit you quickly. But look down there again for the 4 versus the 8, or the 4 matching the 4. Now, this is a tricky process to do the reboot. And it's not tricky because it's difficult. It's tricky because things are so fast these days that it's hard to tell what is the magic enter BIOS button on your particular computer. So it can be any one of these 4 or 5. I've seen it to be, even hitting the minus button or the plus button. Usually when it starts to boot, there's a little indication in the corner that says hit this to enter the system setup or the BIOS. In any event, start with F8, just hit it as you reboot and it will jump in if it works. If it won't, it's just going to simply boot up and then just simply rinse and repeat and try F9, F12, delete, escape. Now you go into processor options and simply turn it off. It'll probably be called Intel hyperthreading technology. Of course, it's an Intel processor, but hyperthreading is what you're looking for. And then just reboot. From that point on, you're going to be back to your full speed actual cores running SolidWorks. Now, forget everything I just said about disabling that, because there are a couple of places, and not really forget everything I just said, because if you're a CAD person, absolutely take that as the best approach. However, if you do simulation and you do things like rendering, these are the types of things that are going to use your multi-threads. So when we're actually rendering an image, you can see this physically when you look at a render that's taking place with PhotoView 360, is there's tiny squares on the screen that effectively chew and refine each little area of the screen. And the more cores that you have, the more little areas that are being refined simultaneously. So rendering is an interesting way with that. Simulation, that's really, really heady code. That type of stuff has a lot of differential equations, simultaneous equations. Things are being solved in parallel quite significantly in tools with simulation at heart. And simulation is more of a basket there. We're talking about structural or flow or plastics or anything that's running these types of algorithms. So those computers will benefit from those multi-cores or the multi-processors. But remember, the rub is still that they're running at half speed. Otherwise, you'd just have an 8-core processor at full speed. So in this case, both of these tools would take use of that. So if you move between simulation and SolidWorks, or simulation or SolidWorks and rendering, maybe having hyperthreading turned on is an okay thing. However, even in that case, we have tools that are more preferential, in my opinion, than utilizing things like hyperthreading. So when you install SolidWorks or when you use the installation manager, there are 2 specific tools that you can install on other computers to get more performance out of both simulation and rendering operations. What you're going to see under product selection are these. You got the SolidWorks Simulation Worker Agent, and then you've got SolidWorks Visualize Boost. And both of these tools are available to effectively farm out the rendering or the simulation process for each of these tools. Now, when you click on these tools and hit the check mark anywhere in the SolidWorks Installation Manager, there's a dialog that happens just below it. And it basically just tells you something about what that tool is, quite verbose, in fact. When you click on the Simulation Worker Agent, what it says is the calculation of SolidWorks Simulation Study can be offloaded from a computer with a license of SolidWorks Simulation Premium to a computer that is running the worker agent. Now, that is very specific. That is from a computer with a SolidWorks license, SolidWorks Simulation Premium to be specific, to a computer running this worker agent, which means if you take your installation manager and you walk around to other computers, you can install this tool. And when you run a simulation, it'll look out on the network for other unused processors that have the worker agent sitting idle, and it'll utilize those cores to assist with the simulation process. So that's a better tool than cutting your rendering and processing in half by using hyperthreading, while instead just using unutilized cores on other systems. And in most cases, you have underutilized cores on secretarial machines, front office machines. If they're quad cores, they're running office and applications like that. They don't need 4 cores. So it'll take whatever's available and it will grab those. Now, when we talk about Visualize Boost in a very similar type of way, what it will do is instantly increase the rendering speeds. Basically, it's Visualize Professional. When you put Visualize Boost on those other machines, it will do the same type of thing. Looks for the processors, utilizes them to farm out the networking of these renderings. So better ways to utilize full cores that are out there that just simply aren't used on these other machines. Okay, let's move to video cards. This is really probably the #1 consideration when it comes to a computer, because the wrong selection in a video card can make a computer unstable. It can make it very clunky, very jittery. And a good video card can elevate even a mediocre computer. So we want to stick with the right type of video card. Now, simply the talk there is OpenGL versus any type of gaming card. Gaming are great for live action, but OpenGL is engineering graphics. That's what it's all about. Now, when you talk about video cards, there are some specific things that I'm looking for whenever I'm filing through a specs sheet or a PDF on video cards. What we're typically looking for are things like the bandwidth or triangles per second or some sort of number that's giving you the throughput like it would for, say, a hard drive, for example. That's basically its rendering or its painting speed, and that's a quick, easy number to find out the speed of a card. Now, RAM is another thing you're looking for. Of course, just like a computer, the more RAM you have, the more processing space that you have available to you. So we go ahead and consider that number to be, again, an easy number just to bundle up there. To find out if a card is good or middle of the road or low end. And then, of course, price. Now, price is always a consideration. I don't care who you are. If we had unlimited budgets, we'd just have the best of everything. And of course, that would just be overkill for everyone. So price is always a consideration. And to be quite honest with you, I would have to believe that this is really the order that things are looked at. You say, how much do we have to spend? And then you see what you can get for those dollars. So money always is king in this. Now, forever, we've always looked at these video cards and we've pined for what we couldn't have. So what we have here is a Quadro RTX 8000, and it is a beautiful $5,500 per card. Now it's free shipping, so that's great. However, unfortunately, it limits you to 5 per customer. So you're going to have to get them in a couple of different shipments. So I say that with a little tongue in cheek. When we're talking video cards, I don't know many people that have the $5,000 video cards. Here's another one that's certified. It's an $8,999 video card, the GV100. However, it's out of stock, so apparently that one's pretty popular. Now, if you're not doing Super Bowl halftime commercials, you really don't need a card like this, and that's always been the recommendation. Now, the one on top has 48 gigs of RAM. That's incredible. Don't even know what the one down here is. It's just way too expensive to even consider. What we also have, these are about a month-old prices, is the PNY NVIDIA Quadro P400. And that's at a really lovely discount of 31%, available for a little over $100. Now, this is also certified for SolidWorks, just as the other two video cards are. When you're looking at what you need, you really have to consider, obviously, the complexity of what's on the screen. Now, a lot of people knee-jerk and say large assembly, size of assembly. And that's not necessarily the case. You've got to think of what it's displaying and the complexity of that. Because a large assembly of 100 very organic parts, that's very expensive to a video card's triangle display. But maybe 10,000 prismatic machine parts, those are pretty simple, so those wouldn't be quite as stressful on the computer. So you got to consider really, again, what the complexity of what's on the screen. Now, if you go to the NVIDIA website, what you're going to see are charts like this. These charts are endless. They're updated constantly because they're just giving you the new specs of the new lines. What I look for in this particular case now is this line right here, which is the version of OpenGL that it supports. And in this case, we're talking OpenGL 4.5. Now, if you look at any of the video cards that we have over here, we're talking anywhere from the P400, right down here below the P500, so it's about the same specs there. You get up to that GV100. These are really high types of specs. And we'd always go through and look for your throughput. So here's your triangles per second type of thing, and then you're going to see your RAM. So those are the things that we actually want to see. Excuse me, those are CUDA cores. Got the little thing off of there. But 4.5 is a significant thing, and that's where I wanted to go next with this. Because we've always said RAM and bandwidth. Those are the things you're looking for, because we've used for the most part, exclusively just RAM in our graphics calculations up till now. But now what we have is a situation where the processor actually matters. We've always told everybody that you could go between the $100 and the $9,000 card, but once you get about halfway, there's a diminishing return for your dollar. The processors got better, but the RAM didn't. Well, now the processor does matter, so you're going to get every little bit of horsepower out of whatever video card you pay for. And that leads me to why I'm talking so emphatically about OpenGL 4.5. Now, we're talking OpenGL 4.5. That was something that updated with the release of SolidWorks 2019. In fact, we're actually up to release 411 of the driver, but back with 390, we hit OpenGL 4.5, and here's a list of the cards. Now, I'm more familiar with Quadro cards than I am with Fire Pro, but both of them hit this plateau. We're roughly at OpenGL 4.6 now. But the most important thing is that if your card sits within these, either notebook or aftermarket or available with the computer cards, then you, with the video driver update, will get this new benefit. Now, this isn't just latest and greatest hardware. A lot of times there are these earth-shattering things that happen in SolidWorks, and it requires some hardware upgrades or some of the latest and greatest stuff. But this worked on about a 4-year-old laptop, way back to these Quadro 410s. So the update is going to hit really anybody that's probably running SolidWorks 2017 through 2019 on recent hardware. So this is what we're talking about with this, though. We've got a comparison side by side of SolidWorks 2018, and we're rotating a very heavy model here, but we're doing it using large assembly mode. Now, large assembly mode decimates the quality of the parts. They turn prismatic, and then when you stop rotating, then the detail comes back. And it's an effort to relieve the triangles being painted by your video card. However, when we get out of large assembly mode, now we're showing full graphics. And what we go back to now is the delay and the jittery. So when I drag and I pull, I have to wait, and I get to see the stutter of the model. Now this is 10,585 part assembly, so it's a huge assembly. SolidWorks 2019 though does it like this, and there's no large assembly mode turned on. This is just the graphics. Because we're using the processor, we can paint the image so much quicker. So the delay on the left with 2018 and the same model on the right with 2019. We're not using large assembly mode, we're not getting rid of dynamic highlight or getting rid of textures or any real intense detail. We're just using more of the video card that you've purchased. So it really is a fantastic addition to the product and what we can do from the user experience regardless of the size of the assemblies and the files that you're experiencing. That is with SolidWorks 2019 and a simple video driver update to support OpenGL 4.5. Really, really significant change. Now, if you have SolidWorks loaded already, you can just simply go down to the search. So again, hit the Windows button, go down to the lower left-hand corner there and type RX. And what that'll do is that'll bring up your SolidWorks RX tool. Now, when you run SolidWorks RX, it's going to let you know right away whether you have a graphics card with a supported driver or not. Now, if mine says this, this is what you're looking for. If you don't have that, then you can click the link directly below it and it will take you to the SolidWorks page in order to choose. Now the SolidWorks page is just a simple marching menu set of pull downs. You simply pick the driver that you need for what you have, but you have to know a little bit about the source. Now laptop, it's pretty clear. When you get a laptop with a video card in it, the laptop came with the video card. But when you get a video card aftermarket and you put it into a piece of hardware that maybe you've purchased and built, now you've got to get a different driver. So if your card came in the computer, search for your computer's model when you're looking for the right driver. So I'm looking for an HP laptop or Dell laptop when I'm looking for those. If you purchased that card off of Amazon and then you put it in there and you built your own machine, or as just an aftermarket upgrade, then you want to search for the video card specific driver. It's going to be PNY for the old school stuff, or NVIDIA, or AMD slash ATI, I guess I should have put there as well, because that's what they were called. So that's what you want to do. Came with the computer, get the computer specific for that model. They tweak it a little bit for the BIOS, it's different. So if you get it aftermarket, go ahead and search for that driver. Pretty important consideration there. Okay, so we're going to talk about RAM a little bit. Now there's not a whole lot to really talk about with this. When we're getting into RAM, what we're really getting into are just, the specs. Get what you can afford. But the reality is for most of us, computers coming with plenty of memory in it these days. Go to the hardware settings. This is right adjacent to where the SolidWorks graphics card settings happen to be. So when you pick graphics card drivers, it goes to the pick list. If you hit simple system resources, you're going to go to this next menu. Now, what they're calling for these days for RAM is actually 16 gigs of memory. Now, 16 gigs of memory isn't really a SolidWorks increase. I think we were showing 8 gigs of memory prior to this, and you can see currently 8 gigs of memory for PDM as well. But what happened is that a corporate development told us back in February, they've actually upped this to 16 gigs, not because of SolidWorks, but actually because of Windows. Windows 10 is taking more information, it's taking more resources. And I don't know if you've realized this, but if you go to your task manager and you look at the processes, you start to see a lot of these extra processes taking up a lot of space and holding onto RAM almost like a CAD system does, actually. But what I've noticed more, and I've done this with other applications and had to really worry about this, is I worry about things like Google Chrome. Because if you open up Chrome and get a few tabs open, and Chrome with things like even OneDrive or other types of file transfer protocols, it gets huge, and Google Chrome simply becomes a pig. I've had to turn Chrome off and make sure all the executables are closed before I do things like video editing and rendering because it's such heavy overhead. So those are the kind of things that you really got to look at when you're talking about a computer. These days, again, you buy a computer, it's probably going to come with 16 gigs of RAM, no less than 8 usually. But 32 or 64, reserve that for just a few people out there that need it for a specific reason. And there is a specific reason, and that is if you're importing files. Some companies have a big computer that they use specifically for imports, and essentially it's got 32 or 64 gigs of memory just so you can open up a giant Parasolid or IGES or step file and then let it sit there and chew. Well, we can't get that kind of RAM for everybody, but if it's a walk-up import machine, then that's a nice way to do things. So file imports using RAM specifically means if you get a couple of hundred megs of an imported file, it's going to sit there and process in your RAM, and that's where you might run into a bit of a processing overhead. Even imports and things like our step files, mesh files, things like that these days. So really that's the main thing I wanted to talk about when we got into RAM. The more the better, of course, but then you don't want to spend money on RAM you're never going to utilize. So 32 gigs would be maximum for anybody out there usually these days. Just save your money. All right. Okay, so let's move on to hard drives. Hard drives are one of those things where I guess I consider it a low-hanging fruit somewhat where you can get a performance upgrade, but obviously the problem with the hard drive is you don't just hot swap that and put it in place of your other because of the operating system and everything that resides there. So you really want to consider this when you're purchasing a new computer, or if you have IT that can simply image drives and get them out to you pretty quickly. Basically, solid state drives is where it's at. If you haven't had a solid state drive yet, once you have one, you'll never go back to anything else. And you know, they're small, they're quiet. The price has always been the issue, though. Price has at once upon a time been about $1 a gigabyte, which doesn't seem like a lot, but when you think about things these days, that's $500 for a 500 gigabyte hard drive, and that's really just not all that much. So we're looking at prices on screen here as of about a month ago when I was constructing this. And what we're seeing here is a range of about, right here, we got a 500 gigabyte drive for about $100. That's a little slower, but it's a pretty good drive thus far. Here's a 500 gigabyte drive that's actually only $62 and listed as a pretty desirable in performance. You can even get 120 gigs for 20 bucks. Very inexpensive. What you're looking for with any of these, though, simply is the bandwidth or the throughput. Of course, footprint or size is the first thing you look at because you want a half a terabyte or you want a terabyte drive. But how quickly the data goes onto the drive and comes off the drive is the number that you're really looking for with each of these. Now, when you're looking at a solid state drive, that throughput is great as long as the files are residing on that same drive. Because if you have a dual hard drive laptop like I do, the main drive is a solid state, but then I have a very large and inexpensive traditional spinning drive as the backup for file storage. Well, if my data resides on that spinning drive, then I've got swapping happening between two of those. So the spinning drive becomes a lag. So what I try to do is I put my operating system on my C drive, which is where my solid state is. With that, I also try to put my critical programs like SolidWorks and anything I'm accessing there. And even these days, the way OneDrive works is it's pulling a lot of your document locations in your desktop, so you can work directly off of your C drive that way as well. So it makes it convenient to work in that location. And if those files are on the same local drive, that's fast. But if they're on the same local solid state drive, then that's just bonus. So pretty big deal with that type of information. Now it brings me to local versus network storage. And we get into a lot of situations where we're talking with people about, about where they work from, where their files are stored. Now, 90% of the time, if a data management tool isn't involved, then it's on a network drive. It's some sort of mapped network location. And of course, the trouble with mapped network locations is that we're dealing with the bandwidth of multiple people accessing that same location. So effectively, if SolidWorks files are located out on some network drive, it's like a lot of people with with keyboards and mice and monitors plugged all into the same computer working off of the same location. So you can obviously see that there's overhead concentrated to the file storage location, and then that data has to move through the network. And that really brings me to why PDM even exists. Now, network drives are important because typically IT is involved and there's some sort of backup taking place. Now, that be as it may from a reliability standpoint, working across the network has inherent issues. And there's a reason why PDM exists above and beyond things like just basic revision control and check in and check out. Now, for this, what we're really talking about is more of what's under the hood or how PDM actually functions. Now, when we're dealing with the behind the scenes of how the software deals with it, again, it's like SolidWorks and how it accesses things with processors and RAM and why that's important. Now, PDM, what you're typically combating is that network storage. And what we get is a delay. We get a bandwidth issue because of those files being stored in that common network location. When a computer opens a file from a network location, there's a series of things that happens. And I tried to capture it with a little bit of a workflow built up in PDM. But essentially, the file is out on a hard drive on a server computer. And in order to transfer that file to the local computer, it has to get chopped up into a bunch of data packets. Now, those data packets, plus about 20% extra because some get lost across the way, they move across the network and then they land on your local computer to be reassembled. And then they get used and processed. And then when something changes, they're chopped up and sent back to the server. And it's a round robin constantly with this type of data. And even explaining the process is exhausting. But that's happening constantly because those files reside on that network computer. When you access them from the Z drive, they are still sitting on the Z drive. You just have your computer processing things and throwing it back across the network through the servers and the routers and the switches and everything you've got. Now, PDM combats this by essentially storing the files in the network. But then when you open or access or edit the data, it's copied to your local working directory. So basically, it's your local working folder. We call it a local view. But essentially, that's where the data actually is moved or copied to. I shouldn't say moved. That's not what we're saying. But the data is copied local, and you're working on local copies. So all the processing power and the access between your bus and your RAM and your video and your hard drive is all very harmonious and very quick. Now, you save and rebuild and save and rebuild, and that's happening local. Everybody's doing that individually. Now, when you check files in, then it copies the data back across the network. So it reduces the top image that we have here from all of these constant round-robin processes down to a simple copy out, copy in when a check-in or check-out takes place. Other than that, the horsepower and the computer sitting at your desk is all being utilized. Now, you might not be aware that you're working across the network and you bought new computers and they're simply not fast like you thought they'd be. This is one thing we really want to check into because they're linked to a slower computer, which is going to be the bandwidth funnel that's going to narrow your speeds. So those are some really big considerations when it comes to how PDM combats this by using data management and faster hard drives, but by utilizing the hardware that you have locally instead of working across that network. Okay. So that brings us to input devices. Now with this, I'm going to go back to the webcam here in just a second. But input devices really is something that shouldn't be, kind of taking a back seat here. It's an important thing. Your hand touches the mouse. The mouse is doing all of the clicks and the movement constantly. So get yourself a mouse that you like. Now this is a common Microsoft 3500 3-button mouse. I like this one a lot because it's simple, has 3 buttons, has the wheel in the middle, which is a button, and it doesn't have that tilt wheel left and right stuff for scrolling left and right on web pages. That actually is a difficult thing to overcome when you're trying to do middle mouse button rotates. So this is a simple $20 mouse. I go through these like crazy, but I use them like crazy. Now you can upgrade it to more gaming types of mice. I've got a different one here. Actually, we're going to go back up to that mouse for a second, where I'm really switching over to something that I want to use that's a little bit more interesting, and that's going to be one of these space mice. Now, this has got a few more buttons. In fact, it has a literal middle mouse button next to the wheel. The wheel is a button itself, and then there's a neat little access button in the middle that brings up what looks like a gesture tool if you're doing it in SolidWorks. Now, it also has some side buttons for scrolling, either going forward and back in web pages or programmable. It's simple, it's ergonomic, and it's got this nice shape to it. So for me, it's very easy to pick up with my thumb and forefinger if I want to do that little move that we do when we hop across our mouse to go across our screen. So to me, it's a very comfortable mouse for those types of things. Any way you do it though, whatever mouse is comfortable for you is really what's most important. That brings me to the Space Mouse. Now, this thing has been around forever. Space Ball is an older type of device. We lost the serial port 9-pin capabilities on a lot of those, so those got retired. But now we boiled this thing down to a Space Mouse, and I've got 2 on the screen. One is more of a professional version. The other one is a traveler or a navigator. Now, that's the one that I have right here. This one here is small and simple. It's heavy, so it doesn't move, but it's got a really good feeling. You just kind of pull it up, push it down, it springs and twists. And then it's got 2 programmable buttons. This one is also wireless. These versions now, you can get wireless versions that run on the 5 gigahertz fob, and then the actual mouse there will run Bluetooth or off the fob, and both of those are rechargeable off of USB. Now, these are great devices. If you've never seen one, it's simply about putting pressure on the puck, and that will rotate the part on the screen. So if you push forward or back, the part goes forward or back, up, down, left, right, or twist. Now, these devices also work in applications like Microsoft Office, Google Earth. You can feel like you're a fighter pilot by pushing with the stick. They're really interesting tools, and they work in more places than just SolidWorks. But it's great for being both left and right hand interactive. While you're rotating the model with the left hand, your right hand's on the mouse doing the clicking. Now, the 2 buttons on the side, that being said, I like to go ahead and program those as a control and as a shift. And what that allows me to do is multi-pick by either putting my pinky on the control or my thumb on the shift while I'm rotating, and then my right mouse is actually clicking on the things that I'm trying to actually select. So it's a great way to be able to get a little bit more bang for your buck from your input devices just by adding a little bit more to what's capable there. Now, that is a little bit of a package that's available as well. So you can find these out probably on Amazon, but you can get a hold of us if you're looking to get these types of packages. They're not terribly expensive, Super great for productivity though when it comes to, again, being more interactive with both hands, rotating, zooming, panning, and selecting all at the same time. Touchscreen computers, this is one that I can't really demonstrate because honestly I don't have a touchscreen computer, but the reality is that these are becoming more available. Whether you've proactively gone for a Microsoft Surface or Wacom tablet, those types of devices, or whether it just came with your hardware because you upgraded the video display and it just happened to be a touchscreen. Now SolidWorks is doing whatever we can to try and integrate sort of the old application, the CAD tools that we've created, along with the new input and new interface methods that exist. And you have to bridge the old with the new, otherwise you're just going to turn into a dinosaur. So I think they're doing a really good job of trying to integrate the way that the younger generation actually works with computers. These days, you know, I would buy a mouse with any computer as a absolute, you know, reaction to it. Kids these days, they get a laptop and they don't get a mouse. They just have the touchpad that's on it or the actual touch screen if it's a tablet-based computer. So a mouse is actually getting more and more foreign to the younger generation, and SolidWorks has to adapt. And that's where touch and gesture sketching came in. Now, we actually added these things in order to interact with any type of touch screen. So this could be SolidWorks running through a tablet through the browser. We do that on our online product trials. We also can run SolidWorks on things like a Microsoft Surface or an Acer laptop with a touchscreen. Wacom tablets are very, very common. Now, if you're using a Microsoft Surface, we've got this really nifty puck that you can get there to actually work with these. This is a company called Mako. They make this gas-powered surfboard. It's light, it's compact, but it's super powerful. Carry it right down to the water, throw it in, fire it up, and you are off and going. So here's the puck, and it looks a lot like the actual Space Mouse, but by pushing in or pulling out, you're actually accessing different levels of functionality on that puck to be able to rotate, zoom, or pan. So essentially it looks like gestures that you would see using some right mouse inputs using SolidWorks. Again, another example of an input device that's a different way of approaching it. When it comes to on-screen sketching, SolidWorks started a couple releases ago by adding things like lines, arcs, and circles to our on-screen sketching. This year, with SolidWorks 2019, we went ahead and made enhancements to give splines a capability. In this case, the artist uses a familiar way of sketching by doing on-screen work, and then that automatically puts it into an actual algorithmic-based type of file, an analytic curve. Now that allows us to create organic inputs, but create nice, constant, clean geometry. Also with 2019, if the artist would sketch a slot-based shape, they would get an immediate slot conversion. What's also cool about this is through the gesturing, if you tap the line in the middle, for example, and select it, by simply writing on screen a number, that will add a dimension to the selected entity. Grab the arc, write the number, puts a dimension. Grab the arc, write a number, gets a dimension. And even if you sketch a circle that goes around a center point, it automatically goes concentric, and because it's still selected, you can go right to sketch dimensioning. Now, the real easy things when it comes to interaction on screen are obviously pick and drag, rotate, graphical interaction. And of course, you know, those were taken care of as well. So here, if we do some double tapping on the screen, that'll enable things like Smart Mates, brings up your toolbars automatically. We'll add a couple of concentric mates between the piston and cylinder, and then those will actuate linear. And then a simple pick and drag of this gear is going to activate any other type of gear mates, cam mates, and any linear actuators we get. So obviously those are the things that need to be addressed when it comes to taking the old methods and bridging those with the new. So again, it was a different way to approach things, but really what I feel more is not just what to get is the question, but why to get it. So that's really why I wanted to go a little deeper physically into what we're talking about with processors and how SolidWorks utilizes those, and especially with how we utilize things like our video cards. Each of those is, you know, again, a different consideration, bang for your buck thing, but we don't want to overspend, and of course we want to get enough because we don't want to spend a lot on a computer and then miss it one place and have that be the, you know, the downfall of the bandwidth of the computer. Now RAM, of course, is always a consideration. Get the more the better generally, but you don't want to overspend on this as well, and this is where you can pull back just a little bit if necessary. Go for solid state hard drives, there's no question on that one. And if you do have issues with storing your data over a network and multiple people accessing those data, please call us. Data management exists for this reason, and it has more benefit than just revision control. It's very much a performance tool and making sure that the wrong things don't happen at the wrong time to people. Input devices, go as deep as you want to. You can stick with just keyboard input and a nice 3-button mouse. You can go a little deeper and get more of a fighter pilot type of a look at this by getting some space mice and a little bit more of an upgraded controller and those types of things. Or even just go full touchscreen. Depends on what your shape creation methodologies are, what your past life experience is, what you're comfortable with. But there's a lot of different things for flexibilities for each of you out there. So I'm going to take a second here, and we're going to look a little bit at what might have come up on the questions here and see if I can knock a few of these out real quick. The question interface is really smushed here, so give me 1 second. I'm going to try and go ahead and stretch that out. Okay, so one question is, does the simulation worker agent require a separate license? It does not. It works because it was launched from the license of SolidWorks Simulation Premium. So the person that has the license is the person setting up the simulation. They are then throwing that over the wall to the worker agent to be able to fire that up. Question is, does PDM clean the local computer files on checkout? Security question. It's a good question there, actually. We have a setting that's called Clear Local Cache, and that Clear Local Cache was set up specifically for ITAR compliances and for those where security is a concern. We don't want people leaving a facility with laptops that have files on the computer. So that can be set specifically for the entire vault or very granularly on individual folders. So it allows you to be very specific with maybe standard components like toolbox components would stay in local cache, where other security-based files would be then flushed upon logout of the vault. So that's a great question there. Left-handed space mouse. You can put it on either side. There's just a setting for left or right, I believe, although I have not tried that, so I can't tell you 100%. Oh, I know what you're saying. You're saying the ergonomic part of that. I'll pass that one along for you, Wayne. That's a good question. How much improvement does Visualize Boost make? I have not physically used Visualize Boost, but the theory behind it is that the more cores that you have running, simply the quicker the renderings go. So when you're doing just simple screen renderings, I wouldn't go hog wild and make sure Visualize Boost is available unless you're queuing up dozens and dozens of renderings and wanting to throw those over the wall to the secretarial machines. In a lot of cases, though, if you're doing an animation, which of course is multiple frames per second times multiple seconds, that's where I would start to consider making Visualize Boost a utilizable tool. Make sure I go through the process of testing it out and seeing how it works for me. Single renderings, again, not that big a deal, but if you're doing billboard size things, then it's all relative to the physical size. Let's see, my video card settings, NVIDIA M5000. Yeah, should be able to upgrade that one there. If we go back to that other slide, you'll see that that's going to be in a mobile machine in that particular case. Does the higher resolution mouse pick better in SolidWorks? You know, this is a comfort level thing. I got my mouse kind of moving around the screen, and I know it's jittery there simply because of the way that the GoToMeeting works, or the GoToWebinar. But essentially, I'm getting more and more used to this mouse. It's got a different light on the bottom, so in my case, it's a clear light now instead of the blue light. And the blue light was a departure from the red light. And we found a lot of red light mice were having a lot of trouble even on things like our mouse pads with red patches on them. So I'm finding that my mouse isn't jumping from one place to another based on, say, a pattern or a reflection that it got off of the desk or the mouse pad. But for me, I'm still getting used to it because I spent years and years on the previous mouse. So I'm kind of enjoying the new challenge and getting used to it for what it does to improve things. All right. And I think that's all we have for questions. So with that, I want to just thank everybody for spending 45 minutes with us this afternoon. We are recording this session, so we'll get this up on YouTube as soon as possible for anybody that wasn't able to see it or didn't get enough notes out of it. That said, though, get a hold of any of your sales reps, your account managers, DASI tech support. If you have any questions or just trying to get a hold of us on some more information. We'd love to come out and see what you're doing. It's great for us to see what SolidWorks is being used to create in the world, and we like to help you maybe learn the things that maybe you don't know about how you're using SolidWorks, and maybe you'll be able to squeeze a little bit more productivity about things in your process. So we're always game for coming out and learning what's happening out in the world for everybody out there. So again, thank you very much for your time today, and we'll talk to you soon. Get a hold of us. We're really excited to come out and see where things are happening with all of our customers. So have a great day. We'll talk to you. Thank you.